Today we're going to be discussing properties of parallelograms. These properties will help you in future proofs that you may have when you're dealing with quadrilaterals instead of proofs that just involve triangles like we've been used to doing in the past where we've been learning a lot of different properties with triangles. So today what we're going to do is we're going to start learning those properties of parallelograms. So first off, we're just going to review what the official definition of a parallelogram. It's a quadrilateral with both pairs of opposite sides which are parallel. All right, so for example, we have parallelogram ABCD. Okay, so AD is parallel to CB and AB is parallel to DC. Okay, all right, so from here we actually have a couple properties that that I have right here. Sorry if it's a little fuzzy to read, but you should be able to get the gist down. If not, it is in your book in section 6.2. All right, so the first property is if a quadrilateral is a parallelogram, then its opposite sides are congruent. So for example, we have that QR is congruent to PS and RS is congruent to QP. All right, so we can say that because this figure is a parallelogram, because the opposite sides are congruent. Okay, so from same sort of idea, but just dealing with the angles, the next property we have is if a quadrilateral is a parallelogram, then its opposite angles are congruent. So for example, angle P and angle R are congruent, and angle Q and angle S are congruent. Okay. All right. So the next one we have, and this one really helps with when we need to solve for unknowns. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So that means that x and y should equal 180 degrees. And we learned that yesterday in our classifying quadrilaterals section, but now we're just putting a more of an official theorem or official property on it. Okay. All right, so with that in mind, we can move on to, this is our last property that we have for this section. It states if a quadrilateral is a parallelogram, then its diagonals bisect each other. So that means that they're cutting them in half. So for example, if we were to set the midpoint here, M, we could say PM is congruent to MR, and that QM is congruent to MS. Okay, so with all these properties in mind, we can actually use these to solve some different examples, which we're going to do right now. And they just help with the algebra part of these particular problems. So for example, we have find each measure in a parallelogram. So, sorry, like that. Okay. So we have angle or side NM, and we want to figure out what NM is. So by the property that says that this cuts it in half, we can actually tell that whatever this length is going to be congruent to this length. And we know what that length is. It's 2, so that means that NM is going to be 2. All right, so then with that in mind, we can figure out what that whole KM is, and 2 plus 2 obviously equals 4. All right, so from here we can say, okay, angle JML. So we want to know JML. We want to figure out this angle right here. Well, by the property that states that the consecutive angles equal 180 degrees, if this angle right here is 110, then we could just say, well, if they both have to equal 180 degrees, then we need to do 110 plus whatever that angle is. which is our, at this point, unknown. So we can just subtract 180 by 110, and we'll get 70 degrees. All right, and last but not least, we have angle KML. And that's this smaller angle here that's being created by the diagonal on the side of the quadrilateral. And since we know that this whole angle is 70 degrees, we then can figure out that, and that this particular one is 30, then we can figure out that 70 minus 30 is 40 degrees. All right. All right, now, in this particular problem, it says find the values of x and y. Well, what we learned earlier is that these angles right here are going to be congruent, and that these sides are also congruent. So we can actually set up that y is going to equal 65 degrees because they're opposite angles, and that x plus 4 is going to equal 12. Because these two are congruent to each other, so we can set them equal to each other. So we just solve for x, so 12 minus 4, and x is going to equal 8. All right, so then our answer would just be y is 65, x is 8, and we're done. Pretty self-explanatory. So what I want you to do now is I want you in your whisk to solve this last problem here. We have find the values of x and y. Okay, so we have 2x right here and y plus 3 here. Use those properties to solve for these values, and you can do that. I'm pretty sure you understand the properties. Otherwise, please bring in any questions on in the next class, and we will be good to go. All right, thanks.